Hello, everyone. Welcome to day number 5. Can you believe it? 5 days of being very, very consistent. That is very, very amazing. I can't believe it. I just love the power of being consistent. Even if you just put in 5 minutes every day or 10 minutes every day, it can push you so far. So if you've been learning with me, trust me, it's gonna pay off. Okay. And over the past 4 days, we've been understanding what is Kubernetes, components of a cluster, the Kubernetes API, and today we want to go into objects in Kubernetes. And so let's get started with it without wasting time. All right, objects in Kubernetes. Kubernetes objects, I need to select all this. They're saying Kubernetes objects are persistent entities in the Kubernetes system. Okay. Kubernetes uses these entities to represent the state of your cluster. Learn about the Kubernetes object model and how to work with these objects. Okay. And the next paragraph says this page explains objects. This page explains how objects are represented in the Kubernetes API and how you express them in a .yaml format. Okay, so I'll go on to the next title. It says understanding Kubernetes objects. The next paragraph says Kubernetes objects are persistent entities in the Kubernetes system. Kubernetes uses these entities to represent the state of your cluster. Specifically, they can describe. So this is actually repeating this, okay? So simply an entity, okay, that describes something that is used to describe the system in Kubernetes. Now, here they're saying they describe what containerized applications are running and on which nodes. So remember, in Kubernetes, we have two major systems, the control plane and one or two nodes, okay? The control plane is responsible for managing the entire cluster state, okay? And the control plane has what they call the API server, okay? And the control manager and other tools like etcd that help in managing the entire state, okay? And we also have the nodes, okay? The control plane will help establish, okay, that a node is required, a node is running, and these nodes, like we know, have pods on them, okay? So a pod has a node, okay? I mean, a pod runs on a node, and inside this pod, we have what is called the container system, the containerization system that is responsible for running the containerized application, okay? So this is what this is referring to. It says the objects describe what containerized applications are running. In other words, which applications have we containerized? Okay, like if you're using Docker, it would ask which applications have we Dockerized. Okay, that's what it seeks to answer. Then it says what resources are available to these applications. You know that in programming or in software development, our applications always need they always need resources. Okay, it could be like memory, it could be like storage, it could be maybe disk space for your database, etc, network, okay, input output, and so on. So it says the policies around those applications, the policy around how those applications behave, such as restart policies, upgrades, and fault tolerance. Okay, because you may need to upgrade maybe the the dependencies. Okay, maybe you want to restart an application after upgrading or updating its dependencies, or you may need to stop it to restart it, or you might make it in such a way that in case of this any failure, it is able to pick up on its own. So I will go ahead and read the next paragraph, which says a Kubernetes object is a record of intent. Once you create the object, the Kubernetes system will constantly work to ensure the object exists. A Kubernetes object is a record of intent. Once you create the object, the Kubernetes system will constantly work to ensure the object exists. So it is something that should actually be there. So once it is created, it must be maintained. Then we go on to read by, and they're saying that by creating an object, you are effectively telling the Kubernetes system what you want your cluster's workload to look like. This is your cluster's desired state. If you remember the role of the kube control manager, okay? If I'm to take you back a little bit, because by doing that, that's how we shall understand. So I want to leave this here and open this, okay? I want you to remember, not just to cram, but we need to understand, okay? Components of a cluster. Then I'm going to scroll to the control plane, okay? So managing overall state of the cluster, but this kube control manager, okay, says runs controllers to implement Kubernetes API behavior. When I hover over controllers, look at what it says, okay? This is a reminder, but of course we read this, it says, but of course it doesn't have to read again, because by reading this again and again, and soon we're going to be doing the practicals, it will help us to understand everything. It says a control that watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state, okay? It watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state, okay? Don't forget that, okay? So, and one of the things it does, look at this, okay? It says when we create an object, okay, we are telling Kubernetes that this is our desired state, okay? Our desired state is to have this object, okay? Understand that. Once we create an object, okay, we are telling Kubernetes that our desired state is this object A that we have created. In case that object A has not been created, okay, the role of the Kubernetes system is to make sure that it makes sure that our desired state is reached, okay? So it will move the system towards that. That is why I took you back here to understand the role of the controllers, which says a control loop that watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state, okay? And then we have the kube scheduler, which of course they work hand in hand. For example, if maybe there's no pod which has been assigned to a node, it does that, okay? So I'll close this, but I went back to show you how all this is being repeated in a logical manner, so you don't get confused, okay? Let's go on. It says to work with Kubernetes objects, whether to create, modify, or delete them, you'll need to use the Kubernetes API, okay? That makes sense, okay? And by now, if you've been doing some software development for a long time, you know that API give us an interface, okay, to access platforms and do things that we may not have been able to do, okay, internally, okay. So you may not, without the Kubernetes API, we would not have the internal control of the internal components, okay. We don't have control over the internal components of Kubernetes, but with the Kubernetes API, we shall be able to create, modify, or delete them, okay. And objects are a record of intent, meaning once you create an object, Kubernetes will always ensure that object exists. So they're saying when you use the kubectl command line interface, for example, the CLI makes the necessary Kubernetes API calls for you. Okay, so they're telling us there's a tool called kubectl which makes the necessary API calls for us. Okay, and now this is just the goal. Remember, the goal of this is just to understand Kubernetes, okay, at a raw level. But very soon we're going to start those actual calls, okay. And they're saying you can also use the Kubernetes API directly in your own programs using one of the client libraries, okay. So there's either kubectl, which is a CLI tool, okay, or the client libraries, okay. If I open this, you can see some of they'll show us the client libraries they have, okay. You see they have a library in C, .NET, Go, Haskell, Java, JavaScript, Perl, Python, Ruby. I don't know how many programming languages which are here you can code in. I'm curious to know. I think I can remember some C, I can remember Java, of course JavaScript and Python. Fun fact, I learned Ruby for a day. Not like entirely, but a few things about Ruby, and I ran away from it because of peer influence. Yeah, then they have other what? Things like Clojure, the popular Java, again Java. I saw Node.js somewhere, okay? There's Node.js, PHP, Python, etc. Okay, so those are the client libraries. So you can either use a CLI tool like kubectl, or we can use client libraries. Let me click on this Kubernetes API to see what it's all about. If I scroll, oh, this is what we studied last time. You remember? Yesterday, actually. Yeah, I was just curious, wondering what is there. But it's what we studied yesterday. All right, let's now continue. Object, spec, and status. Now, let's read. They're saying almost every Kubernetes object includes two nested object fields that govern the object's configuration. Almost every object includes two nested object fields that govern the object's configuration. Okay, so it is called the first field is called object spec, and the second field is object status. The object spec and the object status. Okay, and now they're saying for objects that have a spec, you have to set this when you create the object, providing a description of the characteristics you want the resource to have. Okay. So those characteristics, oh my God, I'm going to bite my tongue saying characteristics. Oh my God. So they're saying the characteristics you want the resource to have, okay, are what is what is referred as to the desired state. Okay. Maybe you have 5 characteristics, characteristic A, B, C, D, E, F. Okay. That's what you want the desired state of that object. Okay. Then they're saying the status describes the current state of the object, supplied and updated by the Kubernetes system and its objects. Okay. So if I've understood, okay, spec is talking about what you want to have. Okay. Status is talking about what you have currently. Okay. Because status may not be what you status refers to what you have currently, but it may not be what you want. Okay, so what you want is the desired state. Okay, what you want currently is status, but take note that it may not be what you want. Okay, so we have the current state. The current status describes, like they're saying, the current state of the object. Okay, supplied and updated by the Kubernetes system and its components. Okay, our current state, but remember, our current state may not be what we want. So what we want is described, okay, in the spec. Okay. All right. Now look at this. They're saying the Kubernetes control plane continually and actively manages every object's actual state to manage the desired state you supplied. Are you seeing now this repeating? That is why it was important for us to go from the beginning. Now look at how they're now talking about the control plane. Okay. Imagine we didn't know what a control plane is. Okay. Now, how does right now the question we should be asking ourselves is, and I'm also asking myself this question. Okay. Of course, I know it, but let me bring it to you. How does the control plane continually and actively manage every object, okay, every object's actual state to match the desired state you supplied? The control plane is made of what? A system of components. Okay, remember we have the Kube API server, we have the scheduler, we have the control manager, we have the etcd. Okay, all these work together to make sure that the actual state matches the desired state. As simple as that. And I was talking about something earlier. I mean, something just skipped off my mind. Okay, I mean, one of the about all these components. One of them, okay, actually is responsible for this, which is the Kube controllers. Okay. All right, let's continue. It's now all coming together. So what they're saying, for example, let's read this. For example, in Kubernetes, a deployment is an object that can represent an application running on your cluster. An object that can represent an application running on your cluster. So now they're introducing us to an example of an object, a deployment, okay? And generally, as a software developer, if someone tells you I have a deployment, what comes to your mind? Okay? You know that an application is running, okay? At the basic level, probably. Why is it running? To be used by users, okay? So right now I know that actual state is stored in what is called the spec, and I mean in the status, okay? Status represents is a configuration that describes the actual state, okay? Or the current state. Then the desired state is described in the spec. So where are we? So they're saying when you create the deployment, you might set the deployment spec to specify you want 3 replicas of the application to be running. Okay. So 3 replicas simply means 3 copies. Okay. 3 copies or 3 instances of your application. Okay. So now we know that and a deployment simply means your application running. Okay. But say it's an object. Remember that. And to specify your desired state, you use the spec to specify that you want 3 replicas. So this becomes your desired state, okay? And Kubernetes makes sure that we reach this desired state. So we go on to read and say that the Kubernetes system reads the deployment spec, okay? And starts 3 instances of your desired application, updating the status to match your spec. I've understood this, guys. I hope you've also understood this, okay? If this is not clear, I would suggest you rewatch this, okay? And read the documentation for yourself. Sometimes to understand something, you need to read it maybe 3 times, okay? Which is normal. Don't feel bad about yourself doing that. Even if it means reading it 10 times, who cares? The goal is that you've understood it. If you don't read it 10 times and you want to compare yourself with someone who reads it only twice and understands it, you'll lose out, okay? So compare yourself against yourself. Every time I study, I ask myself, am I better than I was yesterday? That's what matters. So let me tell you again how I've understood this. And if it's gray, don't be afraid to correct me. It says the Kubernetes system reads the deployment spec and starts 3 instances of your desired application, updating the status to match your spec. So like we know that status refers to the current state, okay? But your current state may not mean it's your desired state, okay? Why? Like in this case, as soon as you create your you define what is called the spec, okay? The spec, okay? Showing you what you want. The current status is not the same because just defining the spec does not mean Kubernetes has created the 3 instances. That's different, okay? That's very different. So when you've defined what you want, then Kubernetes reads the spec, okay, and starts the 3 instances. When those 3 instances have successfully been started, then your status is now updated, okay, to match your spec. So let's continue. Let me not deliver the point. So it says, if any of those instances should fail a status change, the Kubernetes system responds to the difference between the spec and status by making a correction. In this case, starting a replacement instance. Okay? Isn't this what we learned about in the first video? That Kubernetes helps us with fault tolerance. Okay? They're saying now for more information on the object, spec, status, metadata, see the Kubernetes API conversions. I do not want to go into that. I'll move on. So let's read about describing a Kubernetes object. So I'll select this entire paragraph. For me, all things totally make sense. I don't know what you guys are saying, you who are watching right now, or those who are watching after the stream, what you say, okay? But yeah, it's not as hard as people say it online, okay? All right, let's go on. It's saying when you create an object in Kubernetes, you must provide the object spec that describes its desired state. Okay, so again, they're repeating this and again. Okay, your desired state is described in the spec, as well as some basic information about the object, such as the name. Okay, because how will you identify the object without a name? Okay, let's move on. They're saying when you use the Kubernetes API to create the object, so they're saying either directly or via kubectl, that API request must include information as JSON in the request body. Here we are. Okay. Sometimes in programming, I was seeing something on X recently. People arguing about what programming is all about. And someone said that in the end, anything concerning software development is all about CRUD, the CRUD or CRUD operations, creating, reading, updating, deleting. It's either one of that. Either doing something concerning creating, doing something concerning reading, reading something concerning updating, and reading something concerning deleting. And there was banter online of front-end developers versus back-end developers. And the front-end guys were telling the back-end guys, you guys are all about CRUD. There's nothing that you do. But anyway, let me not get into that. Let's continue. I'm just happy that they're using JSON, okay, which is something that I know, and I'm sure most of you already know what it's all about. So let's go. They're saying most often you provide the information to kubectl in a file known as a manifest, okay? So we define the spec in a file called a manifest, okay? That shouldn't be surprising. So they're saying by convention, manifests are YAML, okay? You could also use the JSON format, okay? But I think YAML makes more sense. And I think if you saw me when we were building the flight booking application, just to divert, okay? For those of you who don't know, every evening I build a project, okay? I'm building the backend, the front end, the DevOps, everything. Just want to show you something. So you see this is how, I'm just coming here to show you the YAML format. You see this how YAML is what? Format, like this is a format for GitHub Actions, okay? Where I was creating steps automate creation of the infrastructure for my project, okay? After creating the infrastructure, okay, then I deploy it, okay? I run a script that deploys it to AWS, EC2, okay? But inside that EC2 instance, we have Docker installed, and we have the project running using Docker, and things like inbound rules, blah, 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 are all set up, okay? Yeah, so this is YAML, okay? This is YAML configuration. If I show you something else, I think there's something else I worked with that has also YAML. If I open Terraform, you see, configurations are, it has to be like, the goal of why I'm showing you this is, it has to be like declarative, okay? By declarative, I mean, we have to specify and mention what we want, okay? Not how to do it, okay? Don't say, maybe, for example, if I say, if the goal is to have a burger, don't tell me, get oil, mix flour, heat your saucepan, do this, slice this, put this ingredient, and you list out all the 8 steps. No, that's not what we want. All we want is to say, create from a burger. And the steps of making a burger is sorted for us, okay? Make me bread, and the bread is made for us. That's why I like manifests and YAML files or JSON formats, okay? Yeah, they're declarative, meaning you specify the result rather than the steps to get to that result. All right, let's continue. They're saying tools such as kubectl convert the information from a manifest into JSON or another supported serialization format when making the API request over HTTP. Okay. Now I'm starting to think if there's tools like kubectl, okay, convert it to JSON, then why not have the manifest in only JSON? Anyway, that's just my thought. Okay. So this is an example that they're giving us. They're saying application slash deployment.yaml, an example of a configuration. So they're saying here is an example manifest that shows the required fields and object spec for a Kubernetes deployment. Remember, a Kubernetes deployment is an object, guys. Okay, an object. Okay, and an object is made up of two things. Okay, two fields: the spec. Okay, two nested fields: the spec and the status. The spec defines what we want. Okay, it's configuration for what we want for the desired state. So this, for example, this defines the desired state. Okay, this defines the desired state. Okay, when you have the desired state, then Kubernetes uses it to create the actual state. Okay, so it will run, it will look at this file and run it. Okay, to give us the actual state. And actually, you can, since it is YAML. Okay, we can actually read it. Okay, it looks, this is English. I don't see anything hard. You see, they talk about an API version. Okay, and remember we learned about API versions yesterday. Okay, the kind, I think it's talking about the kind of object. Okay, I'm just guessing, but we shall learn later. Is the deployment. We have the metadata, the name, and Nginx deployment. Okay, and I'm guessing we don't have to cram this. We can always pick them up from their documentation. Okay, I'm seeing Nginx. Okay, I'm seeing a container port. See containers, Nginx, the image. Okay, not that hard actually, if you think about it. Okay, so this is how you create your desired state. Let's go on. Okay, so let's give us an example. Let me not go through all this. Okay, to bore you. Let's go into the next paragraph, and we shall learn. Okay, so they're saying one way to create a deployment using a manifest like the one above is to use the kubectl apply command line in the kubectl command line interface, passing the .yaml file as an argument. Here's an example. Okay, so this says kubectl, okay, apply, and of course ahead we're going to do this practically, so don't worry. Kubectl apply -f, I think this is the argument that specifies the file, then the location, the path to the file. Like this one is on a server online. That's why you see HTTPS, okay, to the file deployment.yaml. Then they say the output is similar to this. It will give you this kind of message saying it has been created. Okay. So I find this very, very easy. So if you're enjoying this, share this with people in your network so that they also learn. Learning from documentation is one of the best ways to learn, even in our age right now. I can spend the whole day arguing about that. Kidding, no. But yeah, I believe it. I believe it. So yeah, I see nothing. I've seen something actually. Are you seeing this? Replicas. Replicas 2 says tell, and they have a comment here says tells the deployment to run two pods matching the template. So 2 copies, meaning they'll have we shall have 2 copies of this of the deployment, 2 of them. Very easy. By just doing this, you have 2 copies. I'm loving this. Okay. And for containers, if you don't know about containers, I think I'm going to create a video. Okay, a video or a live stream where I explain everything you need to know about containers, about virtualization, containers, Docker. Let me say everything you need to know about Docker. Okay, because you need to understand containerization and Docker before you can understand things like this. Like if you know Docker, this is very easy. Okay, very easy, because remember, Kubernetes is a container orchestration platform. Okay, yeah, a container orchestration platform. So yeah, love this. So by doing this, we get an output saying that yeah, it has been created. Okay, let's continue reading. Okay, oh, so now they're now actually explaining the format up there. Let's go through it. Okay, that was me speculating ahead, but I could be wrong. Okay, so let's find out whether I was wrong or right. So they say required fields. They say in the manifest YAML or JSON file, for the Kubernetes object you want to create, you'll need to set values for the following fields. Okay, values for the following fields. And just a quick note, of course, if you don't have kubectl, you cannot run this command. Okay, so if you try it and it's not working, don't get upset. And just to tell you, right now the channel number of subscribers is saying 499. I don't know if there's anybody online to make that number 500. That would be so cool. I noticed the number is 499 subscribers. Just tweak it for me to make it 500. Just a moment. I need to get a cup of water. I'll be back. All right. So in the manifest, and remember this manifest can be either YAML or a JSON file, okay? For the Kubernetes object you want to create, you'll need to set values for the following fields. What is that first field they're talking about? That first field is the API version, okay? So they're saying this refers to which version of the Kubernetes API you are using to create this object. Okay, very, very important to avoid, of course, conflict and stuff like that. Okay, but I think this is straightforward. Okay, if this is not your first time in programming, and of course I assume that when someone is learning Kubernetes, it's not the first thing they are learning in tech. Okay, if Kubernetes is the first thing you're learning in tech, then you may find it tough. Trust me. Okay, because you have to understand things like containerization and stuff like that. And if you learn about containers and Docker, then you know what versions. Okay, you learn about versioning and versions. Okay, all right. The next required field is the kind. You see the kind of object you want to create. Okay, in our case, you see the kind of object is a deployment. Okay, the deployment object. Then they say the next one is metadata. They're saying data that helps uniquely identify the object, including a name string, UID, and an optional namespace. Okay, so information, simply information to identify an object. So to identify this object, they're saying you use a name, which is a string, and a UID. Okay, and then you can also have a namespace. So let's go up and see. So the metadata. Okay, in this case, they've only supplied the name. Okay, so this deployment object would be called Nginx deployment. I think that is why when they run kubectl apply, we see that it says Nginx deployment created. Okay, so this is the name of the object. So spec, they say what state you desire for the object. Remember, today we are looking at Kubernetes objects. In and we know that objects have two nested fields. One field is called the spec, which specifies the desired state. Another field is called the status, which specifies the current state. And I told you, and like we have read, the current state does not always mean it is your desired state. You might have the current state, but that's not your desired state. Okay. And Kubernetes always makes sure that your current state meets or matches your desired state. So spec, okay. In this case, it is a spec of what? Of our current object, which is what? Deployment object. Okay. So every object, just like every object, like I've told you, or they have told us, has two nested fields, a spec and a status. What are we dealing with right now? Deployment object. How do we define that desired state? Using spec. So everything under here, okay, is the desired state. Interesting, isn't it? Okay. So what is required? You need to specify the API version of the Kubernetes. You need to specify the version of the Kubernetes API we're using. We need to specify the kind of object we are using. We need to specify metadata, okay, data about the object, okay, which will uniquely identify this object. And an example of that is the name, okay. And then finally the spec, which is our desired state. Let's continue. So they're saying the precise format of the object spec is different for every Kubernetes object and contains nested fields to that object. Yeah, and I told us earlier that they're actually what? Nested, okay? It's actually nested, if you remember that. We're told that it is actually nested. So if I just to show you, you see we have a key called selector, okay? And nested with another key called match labels. And inside it is app, okay? Replicas is just direct. Template, okay, is nested, it has metadata inside it, and metadata has labels inside it, and labels has app inside it, okay? Spec has containers inside it, okay, and has name, image, ports, and ports has container port inside it. That's nesting, okay, something inside another. That's what they simply mean, nested configuration, okay? Now let's move on. Where was I? Okay, I was reading this. So we go to now the next part. It says the Kubernetes API reference can help you find the spec format for all the objects you can create using Kubernetes. The Kubernetes API reference can help you find the spec format for all the objects you can create using using Kubernetes. So you need to cram, okay? People don't cram. Actually, I have a mentor who is a very profound DevOps engineer, okay? He also tells me there's no need to cram this, okay? Let me show you. Let us go to this Kubernetes API. I think they have so many resources here, okay? Like service resources, okay? If I click maybe like on service here like this, I should see stuff, okay? You see they give you what to do, okay? I think kind service. So don't need to cram, okay? Don't cram anything, guys. Just understand, okay? Understand. If you need anything, if you've understood and you need anything, then you'll know where to look, okay? No cramming, friends. Don't do that. And I think this is something I should have told you at the beginning, not to attempt cramming anything, okay? Just understand stuff. Because what if in maybe like you cram this, then after 2 years or 1 year or 6 months, they change your documentation, okay? You'll fail, okay? When they change the documentation, they'll be talking about the same concepts, okay? So don't cram. Let's continue. The same, for example, see the spec field for the pod API reference. If I open this, let us see what they're talking about. Okay, this is it. You see, this is the pod spec. Okay, so pod spec is a description of a pod. Okay, they have container, int container, blah blah blah. Okay, we don't need to know this now. Okay, so go back. So they're saying, let me select this. They're saying for each pod, the .spec field specifies the pod and its desired state, such as the container image and name for each container within the pod. Let me read this again. For each pod, the .spec field specifies the pod and its desired state, such as the container image name for each container within that pod. Yeah, so we know that pods, okay, a node, first of all, we know what a node is. A node is simply a machine, okay, a computer. Inside that machine, we have what is called a pod, okay? And that pod is where a container runs using what they call the container runtime, okay? So if I open this again, yeah, so you see simple stuff, okay? But let me not confuse you or actually confuse myself. Let's go to the same. Say another example of another example of an object specification is the spec field for the status for the stateful API. Okay, so you can open this. These are just examples, okay, to look at. Okay, so this is stateful spec. Okay, so a stateful spec is the specification of a stateful set. Okay, so we don't cram, we look for them in case we need them. That's the whole point. Okay, then they're saying for the stateful state. Now remember, okay, what you need to understand that all these objects, okay, have this spec field. Okay, this spec. Are you seeing this spec? So, okay, just like our deployment here, this deployment has a spec field. Okay, the pod API reference, okay, also has, for every pod, if you want a pod, okay, it also has a spec field. Okay, stateful state also has a spec field. That's the goal. Let me I'm just trying now to simplify it for you to have understood it, okay? What I'm trying to say that all these objects have a spec field. A spec field is where you specify your desired state. If you want to, to describe your desired state, simply look up the documentation. Is what they're trying to say, okay? That if you want a pod, if you want to specify the spec field, okay, for the pod, go to the pod spec field, okay, the documentation, okay? You're saying pod spec is a description of a pod. Find it there, okay? They're saying if you want for the stateful state, find it here, okay? And they're saying the Kubernetes API reference has everything you need, okay? So don't cram, okay? All right, I'll continue. So they're saying for stateful, the spec field specifies the stateful set and its desired state. As simple as that, okay? Then they're saying within the spec of a stateful set, let me read this again. They're saying within the .spec of a stateful set is a template for pod objects, okay? So guys, again, the summary is this. Every object has a spec field which is nested, but the goal is to describe the desired state. Simple. Okay. If you know the object you want, so the goal is first of all to know the object you want. Like in this case, we have a deployment. Okay. So the kind of object is deployment. We have a deployment. So to describe the desired state of this deployment, we use the spec field. If I didn't know what all this is, I simply look up in the API reference. Okay, that's what they're trying to say. I hope that is very clear. Let's continue. Now they're saying that template describes pods that template describes pods that the stateful state controller will create in order to satisfy the stateful specification. So again, remember, controllers are what help us reach the desired state. Don't forget that, guys, okay? Let me remind you. Let me scroll up. I want to go to the Kubernetes documentation, okay? I want to remind you properly, okay, how all the things are linked. And that's why it is important to learn everything from day one, okay? Components of a cluster, okay? If I go back to components and go to the kube control manager, okay? So the same, this kube control manager runs controllers to implement Kubernetes API behavior. What are these controllers? I'll keep reminding you about this. Say a control loop that watches the shared state of the cluster through the API server and makes changes, attempting to move the current state towards the desired state. Now we know how this happens, okay? We know that the current state is moved towards the desired state by watching the spec. And spec is simply configuration. Okay, think about it like that. This spec is simply a YAML file, like we have seen, or a JSON file. Okay, so if that does not make sense to you, let me know what is confusing you. I may help you, maybe re-explain. And if you discover that I've not understood it also well, don't hesitate to let me know in the chat. Okay, you could save me future frustration. All right, let's continue. Saying different kinds. You're saying different kinds of objects can also have different statuses, okay? Different kinds of objects can also have different dot status, okay? Again, the API reference pages detail the structure of the status field and its content for each different type of object. So again, if you want to specify the status field, we look up the API reference pages, okay? We don't have to hassle and do it from scratch. That is what they're saying here. Now they're saying not see configuration best practices for additional information on writing YAML configuration files, okay? This is something I think we can learn later when you're now doing, when you shall be doing the actual practicals, okay? They have here best practices, okay? Like you see this one here, they're saying, when defining configurations, specify the latest stable API version, okay? So these are things we shall discover, okay? Then they're saying, write your configuration file using YAML rather than JSON. They're saying, though these formats can be used interchangeably in almost all scenarios, YAML tends to be more user-friendly. Then you had me earlier complaining why not choose one, okay? But now we know why, okay? So these are some of the best practices, okay, that we shall be checking against and making sure that we add here too. Okay. All right. So these are two. Others we shall. Okay, let's read this. It's saying configuration files should be stored in version control before being pushed to the cluster. They're saying this allows you to quickly roll back a configuration change if necessary. It also aids cluster recreation and restoration. Okay, this is a very important. Actually, very soon I think I'll have to make a video, okay, on maybe version control, okay, an end-to-end video. I'm thinking about making two things, okay, an end-to-end video on version control, GitHub, and then another end-to-end video on Docker, virtual machines, Docker containerization, Docker compose, things like networking in Docker, things like volumes in Docker, etc. Okay, yeah, but yeah, it was good to know about this. Okay, so now I hope, guys, okay, I hope for me this makes sense. Okay, and I appreciate learning everything from day one till now. Okay, it totally makes sense. Okay, so if you feel like you have a knowledge gap, I request you to set time aside. Okay, every day, start learning from day one when we began. Go to day 2, go to day 3, go to day 4, come to day 5. Okay, it looks small, but remember, consistency is what pays off. I'm now seeing a lot that we have read in the past makes sense now, and it will only make sense when we do it again and again. And these guys are actually bringing up these concepts again and again in a documentation for us to understand. Okay, so let's continue. Okay, we are coming to the end. It says server-side field validation. Okay, let me just sip a glass some water here, then we continue. All right, server-side field validation. Let me select this. They're saying starting with Kubernetes version 1.25, the API server offers server-side field validation that detects unrecognized or duplicate fields in an object. This is good, okay? And they are saying, next line says it provides all the functionality of kubectl minus validate on the server side. Okay, so we're learning that this kubectl command validate helps us to validate, okay, that our configuration does not have duplicate fields or unrecognized fields. Okay, so even without installing kubectl, uh, we are discovering that we have learned about two commands. There's kubectl apply, okay, and there's kubectl validate, okay, and we're gonna do them soon, okay, very soon. Just be patient, like I've said. Let's not rush. Let's go further. Let us follow the documentation step by step, okay. By the way, let me tell you guys something. Do you know that this is a way of learning for free without having to pay like $1 million for a course? If we can be very, very diligent, okay, this is one way of doing it using the documentation. And if we can build a community around ourselves and ask questions, and who knows, we can help one another to reach very far. All right, let's continue. So they're saying the kubectl tool uses the minus validate flag to set the level of field validation. It accepts the values ignore, warn, and restrict while also accepting the values true equivalent to strict and false equivalent to ignore. They're saying the default validation for setting the default validation setting for kubectl is validate equals to true. Okay, so I want to read this again to understand. So the kubectl tool, okay, has this validate flag, okay, which is used to set the level of field validation. Okay, and it says it accepts ignore, okay, it accepts warn and restrict while also accepting values like true and false. Okay, so true tells it to be strict with its validation, okay, and false is equivalent to ignore. So true is equivalent to strict, and false is equivalent to ignore. So they explain here. It says strict to say strict field validation on. They're saying strict field validation, errors on validation failure. Okay. So in case there's an error, it should be shown. Okay. We go to one. Say field validation is performed, but errors are exposed as warnings rather than failing the request. So with strict, okay, validation is performed, okay, and errors are thrown, okay, and the request is not successful. So like, let me say like there is a failure. You're told things are bad, okay, but in warning, errors are exposed as warnings. Okay, now I'm seeing where a warning can be bad. I think I will always want to use strict. Probably, I don't know. Just to be safe. Think about it. Then ignore. I say no server-side validation is performed. Okay. I would have to be very confident of my configuration not to use ignore. Okay. So they're saying when kubectl cannot connect to an API server, let me select this properly. They're saying when kubectl cannot connect to an API server that supports field validation, it will fall back to using client-side validation. Okay. When kubectl cannot connect to an API server that supports field validation, it will fall back to client-side validation. Okay. And now they're saying Kubernetes 1.27 and later versions always offer field validation, like we have said. They're saying older Kubernetes releases may not. Okay. And I'm glad I'm learning when this has been introduced. And they're saying if your cluster is older than v1.27 or version 1.27, check the documentation for your version of Kubernetes. Okay. And they're saying what's next. They're talking about these pods, deployment, controllers, but we're not going to get into this next. Okay. We're going to follow the same order we have been following. Okay. So I'm going to find you tomorrow. Okay. At the same time. Okay. Do not forget. Yes, it's going to be a Saturday, but I won't stop learning. Let's meet at the same time and let's read the next topic concerning Kubernetes. Okay. See you soon as we learn Kubernetes. Okay. And master Kubernetes. So you see how knowledge compiles over time if we are consistent. Have a good one and talk to you soon. And of course, those who have been watching the flight booking engine, yesterday I faced a very stupid bug. I faced a stupid bug, which actually would have solved if I had been disciplined from the beginning. Okay, I just left out a header at the beginning by being stubborn and wisecracking. Okay, but we shall get back to it at the usual time for streaming late at night. So bye for now and talk to you soon.